Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, looking at the work that we are covering, we're still on part 2, and part 2 is on the atmosphere. We have started off with the introduction of part 2 by looking at some of the basic information we need to know. The reason for why we are looking at the atmosphere is because when we look at the topic on climate, climate is important within where our atmosphere is. So within the atmosphere, if we can understand the basic phenomena that take place within the atmosphere, then we can also be able to explain the different climatic phenomena. Okay, looking at what we have covered on climate already, we started off by looking at some of the gases which are found within our atmosphere. And for your homework, I gave you 2 activities to work on. The first one, the completion of the construction, showing the different layers of the atmosphere. And the second homework was for you to collect some information about the atmosphere that you will need in your lesson today so that we can complete the task on features and characteristics of the different layers of the atmosphere. We'll start off our lesson by looking at the revision work on what we have covered on the gases found in the atmosphere. And then we will look at a sample of what you should have constructed into your exercise book. And then we will move over to the activities that I wanted or would like us to complete in our lesson today. We looked at the proportion of the different gases in the atmosphere and the changes in the proportion and the type of gases in the atmosphere from when the Earth was first formed, which is 4,500 million years ago. We had oxygen present, hydrogen and nitrogen, and the pie chart should be able to show us the proportion of those 3 different gases. We also looked at 3,500 million years ago, the change in the proportion of those 3 gases, nitrogen, hydrogen, and carbon dioxide. And then 1,500 million years ago, nitrogen, oxygen, and carbon dioxide. And those gases which are present, the main gases which are present in our atmosphere today, nitrogen, oxygen, argon, and others. And for the others, you were asked to make reference to the worksheet which contain the information in table form showing you the other different gases which are available in our atmosphere. Okay, beside that, your homework was the completion of the construction, and that construction was supposed to show the different layers of the atmosphere. We concentrated mainly on looking at the classification according to temperature zones. And for the temperature zones, we were looking at the troposphere, which is the first layer, the stratosphere, the second layer, then the mesosphere, and the ionosphere. Your construction should look something like what is presented here on the monitor, or if you had used other sources to complete your diagram should actually show the different layers accurately, starting from the lowest layer to the surface to the outermost limit. Okay, a chart here on the board perhaps will show some of the different ways in which the atmosphere is actually classified according to zones. We concentrated mainly on the temperature zones. Therefore, we were able to come up with words such as the trophosphere, the stratosphere, the mesosphere, and the thermosphere. The atmosphere can also be classified according to the composition zone. And in the composition zone, you have the homosphere up to about 80 kilometers, and then the heterosphere from about 88 kilometers up to 145 kilometers and beyond. If you look at this first column here on the chart, the red ink or the red marker represents the height or altitude in kilometers. So we start from the surface at 0, we go to 8 kilometers until we come to 145 kilometers. The black ink or writing here represents altitude again, but in miles. But because we do not use miles these days, we concentrate mainly on the metric system of meters, kilometers, centimeters, etc. So here is the equivalent showing that height. So we make reference mainly to the red color. Okay, now we come to the first zone. We've looked at it already, the composition zone, and we come across words like the homosphere and the heterosphere. We also have perhaps the lapse rate index, and this is basically looking at the changes in temperature, the increase in temperature at the different zones of the atmosphere. So we start off from about, on the Earth's surface at 0, up to about, say, 16 kilometers above. What happens is that the temperature tends to decrease, okay, from this point to that point, about 16 kilometers. Then we come to about 16 kilometers to 16 kilometers to about 32 kilometers, and further up into about 48 kilometers, the temperatures start to increase. Then when we reach about 48 kilometers, then what happens then is the temperatures from about 48 kilometers to about perhaps say 80, 82 kilometers, the temperatures then start to decrease. We come to about 80 kilometers and onwards, then we also note that the temperatures increase. So generally, this particular column here would show the lapse rate index, mainly to do with the changes in the temperature. Then this particular column here, which represents the temperature zone, and this is what we have been looking at on our work on the atmosphere. I've already explained that, and also from the monitor in our last lesson, we looked at a sample of this also. The red line, this red line here, generally shows us the change in temperature. We come to the dynamic zone. This is another way of which the atmosphere can also be zoned according to what we call the dynamic zone. And here you have from about the surface of the Earth up to about 80 kilometers, we have the Troposphere. And then above that, the Diffusosphere from about 88 kilometers and further up. This then will make up the classification for the dynamic zone. And then finally, we could also classify the atmosphere according to the other gases zone. And here we have the ozonosphere from the top of the clouds, which is approximately about 16 kilometers from the surface, not from the bottom, but from the top of the clouds, because about this area now we are coming to the second layer of the atmosphere, and that's the stratosphere. So ozonosphere up to about this point here, which is 40 kilometers, and then from about 40 kilometers and onwards, then we come to the ionosphere. And this is according to the other gases. Okay, that's what we have looked at so far. Today, what I'd like us to move on to, we'll be looking at some of the characteristics or common features for each of those different zones of the atmosphere. And we are going to concentrate mainly on 3 zones of the atmosphere according to the temperature zones. So I will want you now into your exercise book to actually construct a table. And your table should look like what is presented here on the monitor. The instruction is simply for you to discuss and complete the table from the information you have collected and also from the information you have on the different characteristics or feature of the 3 main zones of the atmosphere. So the first column, you are going to put down the 3 zones of the atmosphere. And the 3 zones are the Trophosphere, the second zone is the Stratosphere, and the third zone is the Ionosphere. The second column, you are going to put the height in range in kilometers. So the height is not going to be the exact height at which this particular zone starts from and goes to. Because in different books, you are going to find that there is variation in the height to the limit of each of those different zones. So we are going to look at a range of height in kilometers for each of those zones. That's the second column. On the third column, this is where you are going to make a list of the different features and characteristics of each of those 3 different zones of the atmosphere. So what I'd like you to do now is to make note of the table into your exercise book, and then I'm going to ask you to go or to move into pairs or in threes or fours for your discussion. I'm going to give you time for discussions, and then later we're going to get you to report back, listing down the different characteristics and features of the different layers of the atmosphere. Okay, make note of the table first, and then we'll move on for our discussion. Okay, have we made note of the table? Okay, for the discussion, so that you know exactly what you're supposed to do. The handout or the worksheets that have been distributed, as well as whatever you have collected on the atmosphere, you're going to use those so that you can fill in the table for characteristics and features. To help you along, if you can make reference to page 5 of your booklet. Page 5 of your booklet. Okay, looking at page 5 of your booklet, you can see from that cross-section given on figure 7, some of the features and characteristics found within the different zones of the atmosphere. So if we are going to actually start from the first, which is the troposphere, one of those given is the zone of weather. Okay, that's a characteristic of the troposphere. So you've got to explain in your discussions, try to see what we mean when we talk about the zone of weather. That's only one. There are many others that you should be able to compile or put together in that column. We move on to the second one, the stratosphere. There should be some features or characteristics of that particular zone. Then you come to the last zone, which is the ionosphere, and there's a couple of things which are actually listed or given from the example on figure 7. Your task, discuss other features or characteristics and complete the table. I'll give you about 10 to 15 minutes for discussion and completion of the table, and then we are going to get you to report back, explaining those different features that you are going to discuss and make a list of. Okay, so it's discussion time now, so you can work in pairs, threes, or fours for the completion of the table. Okay, good. So if you've got it that way already, well done. So what you're going to do now is, with your person sitting next to you, you discuss and see if she's got some other features that you might not have got down, and then you can expand. Because this is what I wanted you to do for your homework, to collect and put together, so that when we discuss, we'll have a variety of characteristics and features to go with the different zones. If I ask you the question, where does the mesosphere and the thermosphere come in? Okay, you need to check now on the worksheet and check on what you have collected. Check on the board also. Definitely, their characteristics or features. I gave you an example, like in the first one, the zone of weather. These are also meteorites, are characteristics, but where do you find them, on which zone? Do you find them on the troposphere, stratosphere, or ionosphere? Why? That's right. It is also. Mm-hmm. Well, definitely. Those are all characteristics. That's correct. Okay, you remember I said height has to be range. So I don't want just 16 kilometers from what to what. So that's what we mean when we talk about range. So 16 kilometers is okay, but from what to what? 16 kilometers to 100, or is it from? So you give a range, yes. Were you able to answer the question? Between where does the mesosphere and the thermosphere come in? Definitely, yes. So we go from the troposphere to the stratosphere, and then at the edge of the stratosphere comes the ionosphere. But then before you reach that, you come to the different layers again. In the ionosphere, there is the mesosphere, then there is the thermosphere, and then the furthest outermost limit, which is the exosphere. But all of those are within the ionosphere. We're discussing interest. Okay. Let me have a look at it. This is the zone of weather, zone of life, planes travel, clouds are formed, temperature decreases with what? More information. Temperature decreases with height, so it's better to say that, okay? So maybe temperature decreases with altitude. Okay, temperature clouds are formed, okay, good. How about temperature? Okay, you've got temperature there. Um, Between 8 to 60 kilometers is, okay. Go on to the next one. Any others? Work in pairs so that you can come up with your answers. Well done. You need to sit down, move closer to where she is, and then you can discuss some of those things while they're making note of it. Move across. You've got what? Can I check what you have done? Okay. So we've got as one goes up, the distance of one plane everywhere within the there is a decrease of 6.4 degrees Celsius. Okay. In other words, simply, the higher up you go, the temperature decreases. The lowest layer, yes. Okay. All the water vapor and clouds are formed within the troposphere. Yes, definitely correct. Regular decrease in temperature with increase in altitude, same thing. This will go up there. Okay. Good so far. Go move on to the next one. Next information on the stratosphere. Yes. Mm-hmm. Yes, this is to do with um, positive, yeah, from 0 to an increase in temperature and from 0 to a decrease in temperature. Yes. So that is what is supposed to show there too. So the decrease, that means the negatives come towards the left side and then the positive, yes. It's the same. Yes. You see the decrease, the higher up you go, the temperatures decrease if you're going towards the left, and then to the right, it's positive increases. Your leg down. Yes. What do you think? Definitely, yes. So you see the stratosphere. The stratosphere, it goes up to about, if you look at, say, the Lapse rate, and if you also look at the other gases zone, that might be able to help you. See the arrow? It goes to about 48, to about 50, and then it stops there. Okay? And that's the end of the stratosphere. After that now is the ionosphere. And from the ionosphere, you start off with the mesosphere, the thermosphere, exosphere, and it continues to the outer limit. So definitely you are correct to saying that the mesosphere and the thermosphere are part of the ionosphere, correct? Mm-hmm. No, you just simply say range starting from here to that point. So from where it starts to what point, that's the range I want you to give you, not to do any subtraction or anything else. From 0 to, yeah, 0, starting from here, 0 to whatever, and then from where you stop to the next. You see the height, wants you to give height, range in kilometers. So you're supposed to give a range. I don't just put one number because a one number will not give the range. Range is between a couple of numbers from this to that. So 18 is okay, but between what to 18, and then from 18 to 50, and then from 50 to whatever. We class, perhaps it will be a little bit more easy. Share your ideas and then. I'll give you another 2 minutes and then we will look at compiling and putting together those different characteristics of the 3 layers of the atmosphere. The atmosphere has no limits to it. It goes exactly. You might be better in the showing that because I don't know what the sign is, but it's continuous on. Okay, we'll discuss this together now and we come up with some of the features and characteristics of the different layers of the atmosphere. Okay, we'll look at the first one, the Trophosphere. We'll start from the frontier, Val. What was the range after your discussion that you came up with for the height of the Trophosphere, which is the first layer of the atmosphere?
From ground level, 18 kilometers upwards.
Okay, from ground level, or we can say from 0 kilometers, from 0 to about approximately 18 kilometers. Okay, good. We double check.
That's in the equator. But from the poles, it's from 0 kilometers to 8.
Okay, so Val has gone further to giving us very important information too about the range in height of the first layer of the atmosphere, which is the Trophosphere. It ranges from 0 to 18 kilometers, but at the equator, it is about 18 kilometers above. That's how high the Trophosphere can actually go up to in terms of that zone. At the poles, it's a little bit lower. It's about 8 kilometers. So from 0 to 8 at the poles and 0 to 18 kilometers at the equator. So if you look at the way the Trophosphere is actually shown, it is actually not shown in a straight line across. In some diagrams, you will see that the cross-section will show the Trophosphere closer at the poles, but further up or higher at the equator. So if you had a range of between 0 to 18 kilometers, you could give yourself a tick. And if you also did mention that it's 0 to 18 at the equator, and it's about 0 to 8 kilometers at the poles, then you've been specific. Well done. That is one of the characteristics also if you had included that. But we're looking at the height, so the range of figures to give for the height of the troposphere as shown here. Okay, this time we look at a list of characteristics now. Moses.
Contains 80% of air in the atmosphere.
Okay, so it contains, the troposphere, very important, contains 80% of the air in the atmosphere. So that is where most of the air is actually concentrated around. That is the reason also for why pressure is actually high, lower on the surface, and it decreases as we go up higher. Okay? Very important characteristic mentioned there. Other characteristics? Gideon?
It's the first layer above the Earth's surface.
Okay, very good. We're looking at a characteristic which is simple. It is the first layer above the Earth's surface. That is the troposphere. Okay, that is a feature or characteristic. Number 3. Or the next characteristic.
It contains the zone of weather.
Okay, contains the zone of weather. Shelley?
The troposphere contains most of the water vapor, dust, and clouds in the atmosphere.
Okay, very good. Here is another characteristic. The troposphere contains most of the water vapor, dust, and clouds. We're looking at the zone of weather, and the zone of weather will also include water vapor, clouds. They all come together with the weather. So therefore, by saying the zone of weather, it also is proven with this particular statement that is given for the characteristic. Any other characteristics of the troposphere?
The higher the altitude increases, the temperature decreases.
Okay, very good. We're looking at temperature now and altitude. So we can say temperature decreases as altitude Okay, so the higher up we go, the temperatures then tend to decrease. And that is within the troposphere. Any other characteristics? Francis? Kiran? Any others to include? Catherine? Celesi? Rovio?
There's 58.4% of the total mass of the atmosphere within the troposphere.
Can you repeat that again, please?
58.4% of the total mass of the atmosphere are within the troposphere.
Okay, 58.4% of the total mass of the atmosphere is within the troposphere. In other words, it contains 80% of the air, of which that air has weight, and that weight is actually exerted then within the first layer of the atmosphere, which is the troposphere. Okay, very good. That's a very good point. That is another way of looking at that same information as given here. Caleb, any other characteristics we need to include for the trophosphere, the first layer of the atmosphere?
It is the zone of life.
Zone of life. Plants, trees, animals, people living within this particular layer. Not floating in the air, but actually on the surface, but within this particular zone. So therefore, it can also be considered as the zone of life. Gibbs, any other characteristics to be included?
The air gets thinner when rising height
The air gets thinner
as rising height
as the height
rises.
rises or increases. Okay? What Gibbs is actually looking at now is pressure. Okay, the higher up we go, the thinner the air becomes also, and the pressure also decreases. Here we looked at the temperature. We can also include pressure here. With pressure, the higher up we go, pressure decreases. Okay, so if you're at sea level, the pressure is high. As you go to the top of Mount Everest, the pressure becomes lower. So the higher up we go, the pressure decreases. Any other characteristics to be included? Okay, Gideon from the front.
It is the smallest layer in terms of size.
Okay, when you're making a comparison with the range in terms of the height of the different zones of the atmosphere, you will tend to find that it is the smallest in comparison to height with the other layers or zones of the atmosphere. So when we look at the range from 0 to 18, and perhaps when we look at the stratosphere, the range might be a little bit more higher and or bigger. And when we look at the ionosphere, we might find that the range is even greater. Any other characteristics to be included here from the class generally? Celesi?
It is the zone where vigorous mixing of air transpires.
Vigorous movement of?
Mixing of air transpires.
Mixing of air transpires. Okay, very good. We can also put in here another important characteristic within this particular zone is also the movement of air vertically and horizontally. Within this particular zone, air movement is vertical and it's also horizontal. When we come to the next layer, we are going to find that the air movement is actually going to be mainly horizontal. So this point here is important. Okay, class, perhaps with this information for the first layer of the atmosphere, we will stop here since we have already come to the end of our time for the completion of the work. And we will continue on in our next lesson with the completion of the characteristics of the second layer of the atmosphere, which is the stratosphere, and also the third layer, the ionosphere. Okay, we make sure this information is copied and made note of into our workbook. And class, if you can now stand up, that also brings us to the end of our lesson. To the pilot teachers, our keyword for lesson 91 is ionosphere. Good afternoon and thank you, students.